The National Electrical Code provides two methods for calculating residential service size. Firstly, the standard method as described in Article 220.82, and secondly, the optional method as described in Article 220.82. The optional method operates under the assumption that certain appliances are unlikely to operate simultaneously. However, this assumption may not always hold true. The standard method, when applied, results in a calculated service size of 206 amps. The optional method yields a significantly lower value of 77 amps. A critical consideration is the water heater, which exhibits a maximum demand of 116 amps. If the optional method is employed, resulting in a 100 amp service, the water heater's demand could potentially overload the system. The standard method represents the most conservative and safe approach. It ensures the service is adequately sized to accommodate all plausible load scenarios. While the optional method might seem attractive for its potential to reduce service size, it introduces the risk of overloading if multiple appliances operate concurrently. Given the high demand of the water heater, adopting the standard method is advisable. Using the optional method in this specific instance might contravene NEC Article 220.82. This article stipulates that the calculated load should not surpass 100 amps for a 100 amp service. Therefore, the recommendation is to calculate the service size using the standard method. This will guarantee sufficient capacity for all conceivable load conditions, including the water heater's operation. If competitors secure the bid by employing the optional method, it is crucial to notify the authority having jurisdiction, or OJ, regarding the potential for service overloading when the water heater is in use. Additional factors to consider include, firstly, whether the water heater can be connected to a dedicated circuit or subpult to prevent main service overloading, and secondly, the possibility of using a more energy-efficient water heater characterized by lower demand. When calculating electrical service sizes for residential buildings, the National Electrical Code provides two primary methods. Firstly, the standard method, outlined in Article 220.82. And secondly, the optional method, detailed in Article 220.82. The optional method relies on the assumption that not all appliances will operate simultaneously, an assumption that may not always be valid in real-world scenarios. In a particular scenario, the standard method calculation results in a service size of 206 amps, while the optional method suggests a much smaller 77 amp service. A key component in this scenario is a water heater with a maximum demand of 116 amps. This high demand poses a potential risk. If the optional method is used, leading to a service size of only 100 amps, the water heater could easily overload the entire electrical system. The standard method offers a more conservative and inherently safer approach to service sizing. It ensures that the electrical service is adequate to handle all possible load combinations, providing a buffer against overloads. The optional method, while potentially cost-effective by allowing for a smaller service size, introduces the risk of overloading the system if several high-demand appliances are used at the same time. Given the significant amperage draw of the water heater, it is prudent to favor the standard method in this case. Choosing the optional method in this scenario could be interpreted as a violation of NEC Article 220.82. The section of the code specifies that the calculated load for a 100 amp service must not exceed 100 amps. Therefore, the recommended course of action is to utilize the standard method for calculating the required service size. This ensures that the electrical service has sufficient capacity to handle all anticipated loads, including the water heater, without risking an overload. If competing bids are based on the optional method, it is crucial to inform the local authority having jurisdiction, OJ, of the potential for overloading the service, particularly when the water heater is in operation. Several additional considerations should be taken into account. Firstly, explore the feasibility of connecting the water heater to a dedicated circuit or even a separate subpanel. This would isolate its high amperage draw from the main service panel, reducing the risk of overloading the main service. Secondly, investigate the possibility of installing a more energy-efficient water heater model. These models typically have lower wattage ratings and therefore lower amperage draws, reducing the overall load on the electrical service. The NEC provides two methods for calculating electrical service for a residence. Firstly, standard method, detailed in Article 220.82a, and secondly, the optional method, as per Article 220.82b. The optional method hinges on the idea that certain appliances won't all be running full tilt simultaneously. However, this might not always be a safe bet. Let's consider a scenario where the standard method points to a 206 amp service, but the optional method suggests a 77 amp service would suffice. Now, throw in a water heater that can pull up to 116 amps. If you go with the optional method and install a 100 amp service, that water heater alone could overload the entire system. The standard method is the more cautious route. It makes sure you've got enough juice to handle everything running at once. The optional method might save you some money on the service size, but it's a gamble. If too many things fire up at the same time, you could trip breakers or worse. With a power-hungry water heater in the mix, sticking with the standard method is a smart move. Using the optional method in a situation like this could be seen as bending the rules of NEC Article 220.82b. That article basically says you can't overload a 100 amp service. The safest bet is to calculate your service size using the standard method. That way, you know you're covered, even when the water heater is working hard. If someone else underbids you using the optional method, it's worth letting the local electrical inspector know. They can flag the potential for overloading the system. Also, think about a couple of things. Firstly, could you put the water heater on its own dedicated circuit or even a separate subpanel? That would keep its high amperage draw from affecting the main service. Secondly, is there a more energy efficient water heater option? A lower wattage model would ease the strain on the electrical system. When determining the appropriate electrical service size for residential applications, the National Electrical Code, NEC, provides two distinct methodologies. Firstly, the standard method, as outlined in Article 220.82, and secondly, the optional method, as detailed in Article 220.82b. A fundamental difference between these methods lies in their assumptions regarding simultaneous appliance operation. The optional method operates on the premise that certain appliances are unlikely to be used concurrently, an assumption that may not always hold true in practice. To illustrate the potential implications of these different calculation methods, consider a scenario where the standard method yields a service size of 206 amps, whereas the optional method suggests a significantly smaller service of 77 amps. Within this scenario, a critical factor is a water heater characterized by a substantial maximum demand of 116 amps. This high demand presents a potential risk if the optional method is adopted, resulting in a 100 amp service. Under such conditions, the water heater's amperage draw alone could potentially overload the entire electrical service. In contrast, the standard method offers a more conservative and inherently safer approach to determining the appropriate service size. By accounting for the potential for simultaneous operation of various appliances, the standard method ensures that the electrical service has sufficient capacity to handle all anticipated loads, thereby minimizing the risk of overloading. While the optional method may appear attractive due to its potential to reduce the required service size, it introduces the risk of overloading the electrical system if multiple high-demand appliances are used concurrently. Given the substantial amperage draw of the water heater in this particular scenario, it is prudent to favor the standard method for calculating the necessary service size. Opting for the optional method in this case could potentially be construed as a violation of NEC Article 220.82b, which stipulates that the calculated load for a 100 amp service must not exceed 100 amps. Therefore, the recommended course of action is to utilize the standard method for calculating the required service size. This approach ensures that the electrical service possesses adequate capacity to accommodate all anticipated loads, including the operation of the water heater, without jeopardizing the integrity of the electrical system. In situations where competing bids are based on the optional method, it is essential to inform the local authority having jurisdiction, OJ, of the potential for overloading the service, especially when the water heater is in operation. Furthermore, it is worthwhile to explore several additional considerations. Firstly, investigate the feasibility of connecting the water heater to a dedicated circuit or even a separate subpanel. This would effectively isolate its high amperage draw from the main service panel, thereby reducing the risk of overloading the primary service. Secondly, explore the possibility of installing a more energy-efficient water heater model. These models typically exhibit low wattage ratings and, consequently, reduced amperage draws, which would lessen the overall load on the electrical service. Consider the implications of both methods and the specific demands of the appliances involved to ensure a safe and reliable electrical installation. In electrical service calculations for residential buildings, the National Electrical Code (NEC) specifies two methods. Firstly, a standard method, as found in Article 220.82, and secondly, the optional method, as specified in Article 220.82. B. The optional method operates on the principle that certain appliances are not likely to operate simultaneously. However, this is not always a dependable assumption. Imagine a scenario where the standard method indicates a need for a 206 amp service, but the optional method suggests a 77 amp service is sufficient. Now, factor in a water heater that can draw up to 116 amps. If the optional method is chosen, and a 100 amp service is installed, the water heater alone could potentially overload the entire electrical system. The standard method is a more cautious and reliable approach. It ensures that there is adequate capacity to handle all potential loads, even when multiple appliances are operating at the same time. The optional method may seem attractive because it can reduce the cost of the service installation, but it comes with the risk of overloading the system if several high-demand appliances are used concurrently. Given the significant amperage draw of the water heater in this particular scenario, it is advisable to use the standard method for calculating the required service size. Using the optional method in such a case could be considered a violation of NEC Article 220.82. B, which states that the calculated load for a 100 amp service must not exceed 100 amps. The recommended course of action is to use the standard method for calculating the service size. This will ensure that the electrical service has sufficient capacity to handle all anticipated loads, including the operation of the water heater, without posing a risk to the electrical system. If competing bids are based on the optional method, it is important to inform the local authority having jurisdiction, OJ, about the potential for overloading the service, especially when the water heater is in operation. Furthermore, several additional factors should be taken into consideration. Firstly, investigate the possibility of connecting the water heater to a dedicated circuit or even a separate subpanel. This would isolate its high amperage draw from the main service panel and reduce the risk of overloading the main service. Secondly, consider the potential for using a more energy-efficient water heater model. These models typically have low wattage ratings and, consequently, reduced amperage draws, which can significantly reduce the overall load on the electrical service. When dealing with electrical service calculations for residential buildings, remember to carefully weigh the benefits and risks of each method, and always prioritize safety and compliance with the NEC.